Hi everyone, welcome to this video. Today we are going to study the effect of one one group factor on an interval level variable. So our dv is the level of well-being and our iv is a group variable that here contains only two groups. So in other terms, it's also called a dichotomous group variable. Because there are only two groups, also called a binary group variable. So we could deal with that situation using a one-way ANOVA, because when we have one group IV and one interval DV, so it's it perfectly corresponds to a one-way ANOVA, except we generally report a simpler form of this analysis, which is actually the same thing in this situation. The simpler form that we report is actually called an independent samples t-test. So let's perform that. Let's click on Analyze. Let's click on Compare Means, Independent Samples t-test. So here our test variable, which is nothing but our dependent variable, is well-being, and our grouping variable is just the group here. So let me select group and let's put it here in that box. Now you'll have noticed these two question marks. So basically what SPSS is asking me here, and that's why I cannot click OK, is it's asking me which two groups I should compare. So here there are only two groups and I want to compare control with treatment. What we should know first before doing this analysis, and I'm going to show you that, is that these are just the label for the values 1 and 2. So 1 is actually here control and 2 is here treatment. And by the way, if you go to the variable view, you can also see that over there. Right? So 1 is control, 2 is treatment. So I'm actually going to compare group 1 with group 2. Let me click on define groups, and so group 1 is going to be the value 1 and group 2 is going to be the value 2. Let's click on continue, and that's it. That's the only thing that we need to do. Let's click on OK. Right, so it's an output that is a bit similar to the ANOVA output, but it's shaped differently. But notably, what is similar is that we have Levene's test for equality of variance, and it tests the null hypothesis that the variance in both groups are equal, right? So that we have the same variance in the control and treatment group. And here we see that we have we don't see that we have equal variance, but we don't have significantly different variances, so we can still assume homogeneity of variance. Next, here we have the t-test. So if we can assume homogeneity of variance, we should follow the first line. The second line is actually a correction of the t-test for situations where we don't have equality of variance. But here, because we can still assume it, let's see the first line. And so we see that we have a significant mean difference between the two groups. If I have a look here, I actually see that the treatment group has a higher well-being level than the control group, which of course makes sense. And here we also have the confidence intervals of the mean difference. So the mean difference that is here between the two groups. Sorry about that. So keep in mind that this only presents you with the t-test. It doesn't give you an estimate of effect size, right? So SPSS will not give you Cohen's d, which is the typically used estimate of effect size in that situation. Thank you for watching this video.